Hi everyone, my name is Bilal and this is an Arduino bird feeder project that I would like to present. It's basically an image capturing hardware for birds based on a PIR sensor. So it will detect the movement of the bird, snap pictures, and process it in a Python environment to predict the type or the species of the bird. So I'd like to take a minute here to talk more about my project for the potential investors out in the classroom or the potential users. So my project combines cutting edge technology. It offers an innovative solution for bird watchers and wildlife enthusiasts. This will allow you to capture and identify bird species in your surroundings using state-of-art my ESP32 camera module will snap pictures of birds based on motion detection, and it will resize it and process it in a Python environment to predict the model of or the to predict the species of the bird image. This will help a lot of people out there, such as bird watchers or gardeners, also scientists and researchers who are constantly monitoring the wildlife ecosystem. So this will help add more to their data and increase the awareness out there. I'm not going to add a lot into the intro, but because you already have an idea about my project, I just like to stress that this product is not only for entertainment purposes, but also for education. It serves educational purposes and it will help scientists and researchers monitor wildlife around us by capturing data about the numbers and the population and the species or the types that live and in what regions does it live. Uh, so it will help preserve the ecosystem around us for sure. So let's take a look at the popularity of bird watching around the world. So just this is a pretty old image. So, but last I checked before COVID hits, the numbers were still increasing, and North America alone, $41 billion spent annually on birding in US. So with a 287% projected growth. So the numbers are pretty large. 20 million US people enjoy birding trips. It's a large market. So here I'm looking into the existing products that researchers use in for bird identification, and there's a lot of stuff out there from smartphone applications that would listen to your to the birds singing around you, and it would tell you that like what type of bird is that. Or also birding field guides where it is translated into digital format, so you can just scroll on your phone or on your tablet, and it will tell you like what bird live in what spot and which region, so that you can go and enjoy the scene. But I feel that the category I'm falling into here is the camera traps and remote monitoring systems. And just by looking at the smart cameras around you in the market, it's pretty expensive. So I'm targeting here a low-cost product, which came up to be, I believe, like $50. So talking more about market here. Uh, this is an advertising topic. There's a lot of tools out there: digital marketing, influencer marketing, traditional advertising, and direct sales channels. Traditional advertising, I don't think anyone is looking at during these days. That's newspapers and TVs. Influencer marketing also, it's pretty much expensive. The digital marketing, where you can use social media advertising campaigns such as Facebook and Instagram. These platforms have a huge number of users, so you'll be capturing uh, a lot of viewers out there, and it's at a reasonable budget. Also, using direct sales channels such as Shopify from the e-commerce platforms or YouTube. You subscribe to these platforms and you'll get advertised for your product at cheap prices. So implementation is pretty simple. It's a ESP32 module and extended board that will be in deep sleep to preserve the energy, and connected along with a motion detector PIR resistor that will detect the movement of the bird, take a picture along with an LED flash to improve the resolution, and save the picture into SD card module. So these are the schematics. You can see that there's 2 pins on the LED, 3 pins on the PIR resistor, and 5 pins on the SD card. These pins were pretty much available on the extended board for the ESP32 camera module. So here's the circuit hardware of the extended board of the ESP32 module. I highlighted the pins that I used, which were available, and it actually gave me a hard time to figure out this configuration. So you can see 1, 2, 3, 4, 5 GPIO pins that were used for SD card along with the PIR resistor and the LED flash to snap the pictures and save them onto the module onto the SD card. So here's a small demo. You can see like my hand approaching the PIR sensor, and it will flash an LED and save the picture into the SD card. These are the type of images, pretty good resolution. This is the Python environment that I told you about. I trained my model on 3 categories actually, so 3 classes, 3 species of birds. There's an image here displayed from the training data, and here's a user interface where you can upload the image and classify it, and a model will predict the correct species for you. The accuracy is still low. I'm trying to work on it to satisfy customers. It's 60% right now. At least it should be more than 85 or 90% in order to have a good product. So in summary, I was able to produce a low-cost hardware and implement a machine learning technique for bird species recognition. The project will actually contribute a lot on adding data on wildlife monitoring and helping the preserving the ecosystem and helping researchers, scientists, also adding entertainment and will serve educational purposes as well. As you can see, the cost for this product was around $54. So pretty much cheap for the products out there. So for next steps, there's a lot to do. Actually, I'd like to help customers to be to enable Wi-Fi on this product. So this product will be actually powered by a small battery. And if you want to leave it on a tree or if you want to leave it on a roof, you don't have access for it like every minute or so. So I'd like to enable this Wi-Fi feature or Bluetooth connectivity where you can connect to the camera directly and upload the images and process them right away without opening like Python environment and uploading the images manually and trying to predict what kind of bird did you capture. Also increasing the accuracy of the model and at least developing a good casing. So, yep, let me know what you think about my product, and I'm open for any potential investors at the moment. Also, potential designers that will help me mature my product enough to compete in the big market that I showed you.